Do you still eat potatoes when you can generate electricity from it? Welcome to the GP Effect Academy, where we bring clarity to every concept. Today, we are going to generate electricity from this. Yes, you heard me right. If you have missed our previous session, don't worry, you can always catch up. But don't skip for too long, because today's experiment actually connects to what we have learned. By the end of this lesson, you should be able to explain how a potato can act like a battery, also set up a simple powered potato circuit, and you should be able to explain the principle of electrochemistry behind these experiments. Materials needed to generate electricity from potato. First, we need potatoes. As you can see, these are our potatoes. We have 5 of them here. We need our copper plates. These are copper plates. It has been cut into sizes, copper plates. Alright, so we also need our zinc plates. We are going to be using all of this to connect the potato. And of course, because we want to light a bulb, you can see these are our LED bulbs. These are 1 volt LED bulbs that we are going to be using for this experiment. And because we need to connect, we need our connecting wires. As you can see, our connecting wires, it has been attached with an alligator clip. Alright, let's get to work. Before we delve into the practical properly, we need to explain some key terms. The first one is an electrode. What is an electrode? An electrode is a piece of metal that allows electric current to flow in and out of a material. We have 2 types of electrode. We have the anode, which we call the negative electrode. Example that I have here is a zinc plate. And we also have the positive electrode, which we also call the cathode. An example that I have here is a copper plate. So simply put, you can say that an electrode is an entry and exit doors for electron to flow. In this case, we have our zinc plate, which lets electron out, and our copper plate, which is the cathode, which allows electrons in. Another definition you need to know is an electrolyte. What is an electrolyte? An electrolyte is a substance that produces ion and is capable of generating electricity through the flow or the movement of these ions. To start this experiment, you need to insert a copper plate and a zinc plate inside each potato. Now watch me as I insert a copper and a zinc inside this potato. Can you see? We have a copper and a zinc inside the potato. So I'm going to do that until we have a copper plate and a zinc plate for all the potatoes. You can see. Okay, so the next thing we need to do is to connect them with these wires. So like I said earlier, that we are going to be connecting this red to, that's the positive, to the copper, while the negative to the zinc. So watch, I'm going to connect this. Start from here. A series connection like we have done earlier. Okay, so we have this, the zinc to copper, a copper to zinc. All right, okay, so we have the last one here. The last one is the zinc plate left angle and the copper plate here. So before we can check if this can actually light a bulb, let's check the amount of volts we have been able to generate from this potato battery. Alright, so our alligator clip can come to this. You can see. I hope you can see this. See this. Alright, so the positive terminal will be, so you can see, as soon as I connect it with the voltage to the voltmeter, you can see, once I remove it, it goes back to 0, and once I connect it back, you can see it coming up. So here, we have been able to generate about 2.4 to 2.5 volts here on the voltmeter. That means it can power a bulb, because these bulbs, these LED bulbs, are 1 volt. You can see they are 1 volt LED bulbs. All right, so let's see. Let's connect it to the terminals of our LED bulb. Okay, so when you look at this bulb, you can see that this longer part is the positive end terminal, while the shorter one is the negative terminal. So we are going to be connecting this to the positive. I hope you can see the bulb. So by the time I connect this to the negative, see what happens. We have our light. So we have been able to light a bulb. Yes, a 1 volt bulb has been powered. Okay, let's see if you can light another bulb. Okay, let's try this other one. This is also 1 volt. So you can see. So you can see we have been able to power a bulb from the battery, from our potato powered circuit. Alright, so for those of us that did not see the voltmeter moving, you can see our voltmeter is on 0, as you can see. But by the time I connect it with our potato, what happens? Wow. So that shows that there is current actually flowing through this circuit, our potato powered circuit. So we have been able to check how many volts we could generate from these potatoes. Also, we have been able to use it to power our LED bulbs, as you can see. And we have a stopwatch here. Okay, so you can see this stopwatch. You can see it is off. So I've connected the negative end to our negative side. This is where the battery is supposed to be. Can you see the positive terminal? Can you see? Can you see it coming off? Can you see it? Can you see it? So for today, we have been able to power a stopwatch with our potato battery. We have also been able to power a LED bulb with our potato battery, and we have also been able to check the amount of voltage we could generate from our potato battery. The potato contains phosphoric acid, water, and also salt, which acts as electrolytes that allows the ions to move and makes it to conduct electricity. The zinc that we have here is very reactive and it loses electron. So the electron it loses cannot flow through this potato directly, so it has to go through the wire to the positive electrode, which we have here as the copper. So you can see that the wire is connected from the zinc down to the copper. Now, the movement of this electron is what powers. So today, we have been able to learn how potato can act like a battery. We have also been able to learn how we can set up a simple potato powered circuit. And lastly, we have also been able to learn the principle of electrochemistry behind this experiment. Quiz time. How many devices did we power with our potato powered battery? Number 2. Why did we have to boil our potato in a saline solution? And number 3. How many volts were we able to generate from this potato powered battery? Let me have your answers in the comment section. I'm Ganiat of the GP Effect Academy, and I'll see you in the next class. Bye.